It's a bit like we have seen before. Okay. There are different assumptions in what we do. One of them was the one I discussed before, that, and then I'm going to jump to R now and do what's on the slides. God damn it. It's still quitting. I'm quitting soon now. Oh, and I'm having another issue hitting me in a sec. There we are. Oh, wrong. I'm not stressed at all. So we try again. Here's the data. Going down, down, down. Great. Why do I look at this simple box plot? When I talk about model assumption, we already looked at this, maybe just to have a look at the data. But already here we can see one thing that should make us think. Do we appear to have sort of the same level of variability in the three different groups? It's a variability I'm looking for here, right? And of course it's not exactly the same, but it's just a visual investigation. You can compare variances by statistics, but we decided to skip this little detail from our course notes because there are many things, but you're up to reading about that yourselves when you finish this course. Of course, you could test by statistics whether the variances could be assumed to be the same. We haven't given you that procedure, but it's there to be found, right? Just to let you know. For you, you just have the visual investigation. Do the variances appear to be the same? Yes, they do. Is this one different from this one? Yeah, a little bit, but probably not important. You know, that's how you report things, right? I look at it, I don't have a problem with that, I continue, right? And for you as a student, it's also, if we didn't teach you what the heck you should do if you had a problem, then you don't have a problem, right? Here I do the fit, and then we do something which is on the next slide. We should also check normality. Are these things normal? Yes, they are. Please note what happened here. Even though I had 3 groups of data, right? I collected the residuals, 4, 4, and 4. I collected into 12 residuals. And then I look at the normality on all of these 12 residuals. So I pooled together, I joined together the residual information from all the groups. I could, of course, investigate normality in one group, in the second group, and in the third group. And probably you could have done something like that as part of your project if you've done it nicely. But we could also join those residuals and do a joint And that makes good sense, because for this also a toy data set of 4, of course, it doesn't really make sense. As you know, we've discussed, to look at a box or a normality plot on 4 observations looks always pretty terrible anyway. Also for things that are actually normal. So it's not worth so much in that case. We could also do the Wally thing, and I think we prepared that today. I like the Wally plot. Let me see, do we have... I like it when it works. My computer didn't like the Korea trip, it seems. Let's skip the Wally. You know the Wally plot, that's making the 9 plots where you should find your Wally. That is, if you can pick out your one among the 9, you probably have a problem. If you couldn't pick out your one, you don't have a problem, right? You have seen that before? It's your residual plot is compared with similar residual plots as they could look if it was truly normal. So it's a very nice procedure, right? Because we get this additional information about that things also vary. Oh my goodness. Anyway, I'm not going to use R for the last part. So let me just finish the R thing here, and I'll go home and cry a little bit after that. This is what I showed you in the beginning also. It's just to show you that we can do this analysis on the Bang & Olufsen data. And we've already seen some of the results in my panel check, that the products were definitely different on the noise, right? Now I didn't show you in R, you could do that. And for the topic of next time, just to prepare for that, is for us to be able to make extensions of this so-called one-way analysis of variance, and actually take into account that these data came at least in a two-group way, two-way table way, that's what I meant to say. So I had 12 combinations of TV and pictures, yes, but I also had the same 8 assessors or panelist members, the people actually making the evaluations on this. They also were used again and again, just like this paired t-test thing. It is the same assessors that goes in all the treatment. So actually I have 12 times the same set of 8 assessors used for all the products. This is the paired thing, but now it's not only paired, because there are not only 2 times, it's 12 times. Then that's called a block thing. And we're going to be able to handle that. That's extremely important for real-life applications of this, that we can handle that extension also. And in R, it's very easy. It's just like the MLR thing. We just plug in the other column, actually also here. That's the model control. I brought the slides there. I brought the ANOVA once again next week, two-way. That's what I just shared with you. That finalizes the presentation. Then I'm going to spend 5-10 minutes, I hope. What the heck? Interesting.